Hi, he's from EMC. He's one of our hosts, so you get 5 minutes.
So first of all, I'm Thomas Price. I am the director of our North American utility vertical. EMC focuses on just 4 verticals, and it's healthcare, state and local government, and education, and oil and gas and utilities. So that's where I spend all my time, is talking to various companies about how to drive technology into their smart grid programs. So thanks everyone for coming here. It's great to have you at EMC. I did want to mention, Corinne runs our sustainability program. She's done a phenomenal job in driving the programs within Silicon Valley. So, for instance, we have reduced our footprint significantly by just sending people home. So, sounds kind of interesting, right? No, not layoffs. So
We should also ask Corinne about what she's doing in terms of the water management, because it was her idea to not use the water bottles, and it slipped through the cracks in this event. So ask her about it during break.
Yeah, we're actually working from home. I'm an official work from home employee. We've enabled that via technology, so it's great that I can get up in the morning and conduct my entire workday via the phone and conference and video, and I don't have to come in here and turn on the lights and use space. As you walk through here, you'll see that there's a lot of empty cubes, so we're aggressively reducing our footprint just through technology. So what I was going to talk about today was really the data center. So we've talked a lot about residential efficiencies and whatnot, but a huge offender of energy consumption is the data center. EMC has sold our large storage devices into data centers for the past 25 years. One thing we've recognized in the last 10 years is that the technology efficiencies, the technology is growing so rapidly that companies like ours, like Cisco and the other large corporations, are growing and building new data centers. But what they weren't focused on is the energy consumption. So what we've done now is we've developed energy calculators. So when we sell something, we actually can tell you exactly what it's going to consume. The trouble with that is that that's sort of a point-in-time component of energy consumption. The things that we're now driving is actually doing a baseline and then running that baseline, or running from that baseline to tell a CIO exactly what the consumption is at any given point in time. You do that through instrumentation, really software and small mechanical devices. So what we're seeing is that, just to give you some information about data centers and how inefficient they can be, utilization of the systems that are required to run a business should be around 75 to 80%. Where it actually is 35 to 40%. Virtualization through a company like VMware that we acquired a few years ago is actually helping us achieve that 75 to 80%. If you put that in terms of energy consumption, we leverage, we're burning about 61 billion kilowatt hours of electricity. That's the equivalent of 15 power plants, right? So if we can just get ourselves from the actual to the target, then we'll avoid building new coal plants, right?
And data centers use, there's various numbers bandied up, but 2 to 3% of it's a couple of percentage points of our entire electricity usage is to.
Yeah, the IT numbers we see is like IT is about 2% of the total energy.
Yeah. Okay. So if we can affect that, we're actually moving the needle, right? And that's really the point. So our programs are really geared towards, and to the point that was made earlier, you can actually leverage energy efficiency as a differentiator amongst your technology and your competitors. So we actually do that. You start to see that in proposals where it might be a $100 million proposal, and a good component of that is actually the energy efficiency component. So the CIOs and decision makers will buy your technology. You might have the same speeds and feeds as your competitor, but if you're more energy efficient, they'll buy your technology, right? I wanted to make one other comment about what I think it takes to get there. Establishing the baseline is critical. Just data, right? And we talked about how to drive behavioral change. You can't change behavior if you don't have the data, right? So I like to use the example of PG&E. They send me the tiering notification. So here I get the, you're about to violate tier, I'll say tier 1, just so you don't know how much. Plasma screen TV.
You're at home with all that virtual energy.
Right.
Energy now.
So that information, which is core to EMC's offering to the market, is just not there. So if I'm about to violate another tier, they're not telling me what I'm doing, what the trajectory is, how to avoid it. It really is. So in the residential environment, if we just get the data in the hands of the people, you will actually drive.
So we talked about that with O-Power, with electricity usage, with WaterSmart, with water usage. So that's obvious. It can make a huge change without having to discover a new element or create a new piece of equipment.
Right.
Yeah.
Right. So and then taking that one step further. So establish a baseline. Understand how the consumption is. Governance is key. If CIOs don't understand exactly what's happening, if applications are sunsetted or abandoned by the business, you should know that, and you should be able to turn off the technology components that are in place to support that so-called orphaned application. And then making sure you have business buy-in, right? Make sure that the people who are asking the IT organization to produce some feature and function, that they're willing to understand what impact that's having on the environment, and then staying engaged. So when they do abandon or sunset that feature and function, that you're actually able to turn it off. Okay. So I'll leave it at that.
Don, this is sort of in Altera's
I love this.
wheelhouse.
Yeah,
so please, if you have a question,
Yeah, I have to keep it under 5 minutes this time.
please.
One of the big, I suppose, there's still a big opportunity in this IT energy and data center energy efficiency space, and a lot of gains, as you pointed out, have been made through virtualization and so forth. But there's still a challenge in that a data center tends to operate in the on mode more or less all the time. And computing demand, if you think about it, ebbs and flows. So if that data center supports, say, a shopping site, an online shopping site, well, the demand peaks on the day after Thanksgiving, and then at other points of the year it's really low. Ideally, your data center's energy use would map to the computing demands that are being placed on it. And there are some emerging technologies out there for data center power management and optimization that kind of take virtualization to the next level.
So in other words, you have to design your data center for the busiest day of the year, right?
You
It has
do.
to
You have
be
to
able
design
sort
that
of like having-
It's
capacity.
like base power.
Yeah, so how
It's
do you...
like base power versus
Absolutely.
peak power.
Absolutely.
Right, and how do you have the data center map as best as possible to the ebbs and flows of demand, so that there isn't a lot of unused capacity when demand is down. Be interested in thoughts on that, and some of this is a holy grail because it'll never be perfect. But
Guys, there's been a request from the back that you either step up or pass the mic. Thanks.
There's a microphone at your feet. I will. So
I'm finished.
okay, and that.
Well,
Matt,
yeah, I
just-
think
just,
to
in the nick of time.
to
It
address
wasn't
that
personal,
issue,
Don.
to address that issue, there's a lot of technology obviously rooted in cloud computing as one, of being able
Right.
to better average things and have burst capacity, just kind of like we have in some cases in the power system. So I think that is an important thing. But I think another issue here, because as you mentioned before, the data centers, it's only about 2% of total energy usage. For certain kinds of companies, like Google or something, it's a much higher fraction of their spend. But it's still often not as big. And the driver of more efficiency in data centers is sometimes not what you'd expect. For example, we were once working with a large financial company in New York City, and they were told that they could get no more power. There's a limited amount of power in the city. You can get no more power beyond this amount. So they were faced with make the data center more efficient or move to New Jersey. And they decided to invest in efficiency. This is kind of thing in water as well. The price of water doesn't go up that much. So the price of water is not driving water efficiency, but companies like large manufacturing plants and certain municipalities are told you can get no more water above this. So it's become more water efficient or move to
New Jersey. I think we found the ultimate disincentive.
So I think virtualization is a key driver for efficiency. Spin-down technology for the hardware is something that it's growing in popularity. You have a reliability factor with that, but it is driving the efficiencies. I think also, you know, when you take utilities and how they're actually producing electricity, the technology that they're trying to apply to the smart grid will drive the demand response. And it's already been mentioned, but you know, think about virtual power plants. So we're talking about technologies, software virtualization, but think about power plant, actual power virtualization. So demand response companies, if they can instantaneously shed 500 kilowatts of load from the grid, that's the equivalent of a small coal power plant, right? And so that's where you know, that virtual power plant concept hopefully will continue to evolve with companies like Converge and Enernoc. It's fascinating, and it will allow us to avoid you know, burning more coal. Right?
Questions from the audience? Again, Matt.
Yeah, just more a comment that I just, you know, the 2% figure that you quoted, in general, the challenge with the data centers, there's another 50% of energy use in data centers that's the AC to cool the IT.
Yeah.
And that is a huge opportunity as well. Goes to the point Don was making about the cycling of computing demand. In fact, you know, the AC that you use in your home or small business that's designed to handle cycling load is poorly adapted to that 24/7 data center environment. And that there really is a huge opportunity for a better designed crack computer room AC that is, you know, a 24/7 freeway train, high-speed rail of air conditioning load.
That's a good point.
Hi.
To what extent, in terms of this data center issue, are gains being made at the equipment level in terms of the efficiency of using the electricity at the equipment level?
Yeah, it's a very good point. So, question. So if you look at the sort of history of data storage devices, they used to be about this big, and they used to be able to store about 5 megabytes of data. That's back in the early days of IBM. Since then, you have a very small footprint that can hold a terabyte of data. The trouble with that is that they're very inefficient, very unreliable media devices. So as we've gotten more dense, right, people are they're developing more data, which means we're burning more energy trying to keep up with that. What we have done is we've actually evolved into using flash technology, and that flash technology has the same exact capacity. So we didn't go from 5 megabytes with a giant device to a terabyte with a little tiny device. We went with we're at a terabyte with a little tiny device that's 30% more efficient, right, via flash technology, and it's also a lot more reliable. So thus customers are consuming it because they're getting a lot more energy efficient out of that technology, and better performance, right? So they get the best of both worlds with that. So yes, there is, you know, VMware allows you to take your utilization of a server, of a CPU cycle. You know, generally servers that are dedicated to a certain business function will run at 40% utilization. With VMware, you can now stack more applications on that single CPU and increase the utilization to 80%. So the storage technologies and the CPU technologies are benefiting because of better hardware technology and software with things like VMware.
So there are, you know, there are entire events devoted to data center efficiency, right? And that's 2-day events, and there are entire events, you've just come off of one recently, right, that are devoted to energy efficiency. And unfortunately, we have not a lot of time. And that's the problem, I think, with green tech, and even having green tech events. It's no longer, it's like having a semiconductor event. It doesn't, right? It doesn't make sense to do that. I think if there's a trend, it's going to be, let's have less green tech events because all of these warrant their own specialties, right? Some advice for
In defense of